Hello everyone, I am the second reporter and I will be continuing the report. So let's talk about probability. What is probability? Probability is simply how likely something is to happen. Whenever we're unsure about the outcome of an event, we can talk about the probabilities of certain outcomes, how likely they are to happen. The analysis of events governed by probability is called statistics. So for example, when a coin is tossed in the air, the possible outcomes are head and tail. So other major applications of probability, it is used for risk assessment and modeling in various industries, weather forecasting or prediction of weather changes. Now, there are different types of probabilities: dependent and independent probabilities. Dependent probability, dependent events in probability means events whose occurrence of one affect the probability of occurrence of the other. For example, parking illegally and getting a parking ticket. Parking illegally increases your odds of getting a ticket. Buying 10 lottery tickets and winning the lottery. The more tickets you buy, the greater your odds of winning. Then, dependent probability. Though two events are independent, statistically independent, or stochastically independent if, informally speaking, the occurrence of one does not affect the probability of occurrence of the other. Knowing one event occurred doesn't change the probability of the other event. For example of independent probability, you flip a coin and get a head, and you flip a second coin and get a tail. The two coins don't influence each other. Then second, conditional probability. Conditional probability is known as the possibility of an event or outcome happening based on the existence of a previous event or outcome. It is calculated by multiplying the probability of the preceding event by the renewed probability of the succeeding or conditional event. A and B is the probability of event A occurring. Given that even B occurs, for example, given that you draw a red card, what's the probability that it's a 4? P, 4, and red. So equals 2 divided by 26 and 1 divided by 13. So out of the 26 read cards, given a read card, there are 2 4. So 2 divided by 26 equals 1 divided by 13. Then, third, bias. Statistical bias is anything that leads to a systematic difference between the true parameters of a population and the statistics used to estimate those parameters. To give an example, imagine that there are 10 people in a room and you ask if they prefer grapes or bananas. If you only surveyed the 3 females and concluded that the majority of people like grapes, you've had demonstrated sampling bias. We have two type of bias: selection bias and confirmation bias. So selection bias is a distortion in a measure of association, such as a risk ratio, due to a sample selection that does not accurately reflect the target population. Then confirmation bias or confirmatory bias is a tendency to search for and interpret information in a way that confirms one's preconceptions, leading to statistical errors. For example, imagine that a person holds a belief that left-handed people are more creative than right-handed people. Confirmation bias is a type of cognitive bias that involves favoring information that confirms previously existing beliefs or biases. Variance. Variance is a measure of dispersion that takes into account the spread of all data points in a dataset. Variance is a measure of how data points differ from the mean. According to Lehman, a variance is a measure of how far a set of data or numbers are spread out from their mean average value. Variance means to find the expected difference of deviation from actual value. For example, variance. If a if a group of numbers ranges from 1 to 10, it will have a mean of 5.5. If we square the differences between each number of the mean and find their sum, the result is 82.5 to figure out the variance. Standard deviation measures how data is dispersed relative to its mean and is calculated as the square root of its variance. The farther the data points are, the higher the deviation. Closer data points mean a lower deviation. The interquartile range is a measure of where the middle 50 is in a dataset, where a range is a measure of where the beginning and end are in a set. An interquartile range is a measure of where the bulk of the values lie. That's why it's preferred over many other measures of spread when reporting things like school performance or SAT score. Then second to the last, variance trade-off. Variance trade-off is the property of a model and the variance of the parameter estimated across samples can be reduced by increasing the bias in the estimated parameters. It's a way to diagnose the performance of an algorithm by breaking down its prediction error. Then, correlation. Correlation is a statistical measure that expresses the extent to which two variables are linearly related, meaning they change together at a constant rate. It's a common tool for describing simple relationship without making a statement about cause and effect. For example of correlation, the more time you spend running on a treadmill, the more calories you will burn. So that's all my report